So now let us see Gattermann salicylaldehyde synthesis. So this reaction can also be called as Gattermann reaction. Gattermann reaction or Gattermann formylation. It is an electrophilic aromatic substitution reaction. It is an electrophilic aromatic substitution reaction. That is, an electrophile, which is a positively charged compound, is substituted on an aromatic ring. So now here in this reaction, we will be taking aromatic compounds. Specifically, we will be taking a phenol. So now this phenol, it will react with HX, which is a halide, hydrogen cyanide, HCN, in the presence of a Lewis acid AlCl3, which is a Lewis acid, to give us imine, or you can say imine, which is, see this is, first let me draw phenol. So this is a phenol. Here OH is present, OH and imine. So imine is C double bond N, where you'll be getting a H and a H over here and OH. So this is imine. Now this imine, in the presence of water, will eliminate NH3 from here and will give us para-salicylaldehyde. So you can see here a CHO group, that is an aldehyde group, is substituted at the para position. So this is ortho, meta and para, meta, ortho. Here aldehyde group is substituted at para position. So this compound is called para-salicylaldehyde, or it can also be called as, so here at para position you are having OH group, so it is also called as para-hydroxy benzaldehyde. So now let us see the mechanism for this reaction. So first of all, we will be seeing the reaction between HX and HCN. For example, in the presence of X, you can take Cl, chlorine. So here first we will be seeing the preparation of imidoyl chloride from HCl and HCN. So here first HCl will react with HC triple bond N in the presence of a Lewis acid AlCl3. So first of all, here chlorine will take the bond from hydrogen, leaving hydrogen as H plus. Now the nitrogen here will contain a lone pair. This lone pair will donate its electrons to this H plus, giving us HC triple bond N and a H over here with nitrogen, a positive charge. As it shared its electrons, this nitrogen gained positive charge. Now as this is an electronegative group, more electronegative than this carbon, it will take the electrons from carbon, leaving this carbon positively charged. Now this positively charged carbon will form a bond with this negatively charged chlorine. The carbon is getting a positive charge. Now the chlorine Cl minus, chloride ion Cl minus, will donate its electrons to this electron deficient carbon atom, giving us HC double bond NH and a Cl here. So this is imidoyl chloride. Okay. Next we'll be seeing the formation of imine. That is, first we'll write here formation of imine. Here we'll be taking phenol. So first we'll take phenol here, OH. It will react with imidoyl chloride. So when it reacts with imidoyl chloride, the hydrogen present over here will come out in the form of H plus. This bond is shifted over here and H plus is eliminated. And here Cl minus is eliminated. Then this carbon here will get a positive charge. So here HCl, H plus and Cl minus is eliminated in the form of HCl hydrochloric acid and will give us two compounds. Here OH and a positive charge negative charge over here with an electrophile HC double bond NH plus charge. Here a positive charge and here we have a negative charge. Now this carbon will donate its electrons to this positively charged carbon, forming a sigma bond between these two carbons, giving us a structure. Here OH and here we will be writing C double bond NH and a H over here. So this is imine. So now imine is also formed. Next we will be seeing the formation of para-salicylaldehyde. Now we will see the preparation of salicylaldehyde. So here imine in the presence of water molecule, here OH, C, H double bond N, H. Now this imine in presence of H2O. So here you can see NH3 is eliminated first. So how is NH3 eliminated? Now here from H2O, oxygen, it is an electronegative atom. It will take the bond electrons from hydrogen. H plus, hydrogen will come out in the form of H plus. Now this H plus is attacked by the lone pair of electrons present on nitrogen, giving us this structure. Here OH, again CH double bond N, H2H over here, and this nitrogen will attain a positive charge. As this nitrogen here is having a positive charge, it will take the electrons from carbon in order to neutralize its charge. Then carbon here will attain a positive charge. Now this positive charge is neutralized by the OH minus, which is formed over here, this OH minus. Now this OH minus will form bond with the carbon which is present over here, which is positively charged, giving us this structure. CH, here you have OH and H2. Now again nitrogen here will take the electrons from carbon, then this carbon will become electron deficient, then the bond present between O and H, that is between oxygen and hydrogen, is shifted over here and hydrogen will come out as H plus. Then NH3, NH2 minus and H plus will eliminate in the form of NH3, and we'll be getting the final product as para-hydroxy benzaldehyde or para-salicylaldehyde. So this is para-hydroxy benzaldehyde or para-salicylaldehyde. So this is the mechanism of Gattermann salicylaldehyde reaction.